Now, let's look at this numerical or a question which focuses on the exponential family of distributions. So, a portfolio consists of k independent travel insurance policies. Okay, there are k policies. Each policy covers the policyholder's trips over 1 year. For policy I, the number of claims in the jth month covered is Yij, right? Yij, ith policy, number of claims in the jth month. So that is what is coming out as Yij, and it is having a probability density function which is more like this: theta ij times 1 minus theta ij to the power y. So y is the number of claims, right? The probability that Yij equal to y. So now I can so theta ij is nothing but it's an unknown constant which is lying between 0 and 1, and for that I am trying to find out the likelihood function and maximum likelihood estimate. Now what is the likelihood function? This is the probability function, right? This probability function has to be multiplied over all the months because this is for each month. So I have to multiply it over the months 1 to 12, and I have to multiply it over the risk 1 to k. For each risk, right, because there are k independent policies. So for each risk, for each month, so this becomes my likelihood function. And we are talking about obtain the maximum likelihood estimate for theta. So for the maximum likelihood estimate, from the likelihood I will find the log likelihood. So when I am doing the log likelihood, this entire thing, the product will become the summation. So I equal to 1 to k, j equal to 1 to 12, and this is becoming the log theta j, right? This becomes log theta j and plus y log 1 minus theta j. This is the log likelihood. Now log theta j, if I am really adding up, how many such are there? 12k times are there, because for each one there is one theta j. So theta j again would be the summation across all these, and similarly i's are, right, the i's are again from 1 to k. So this is the summation part of it. Now what I really want is, this is some constant, right? There is the j from 1 to 12, so probably I'll call it as theta 11 plus theta 12 plus so on. That is what is finally coming out. And similarly y log something. Okay, the summations are this. Then all we are trying to find out is, because I want the maximum likelihood estimate for both of them, I'll take the derivative of this with respect to, so I'll take the derivative of the log likelihood with respect to theta ij, and equate it to 0. Okay, it becomes 1 by theta ij plus y by 1 minus theta ij times minus 1. This is equal to 0. Now some constant times, because this number is this entire thing is multiplied, is repeated over the same number of times across. So I can very well set this equal to 0, which means 1 by theta ij is equal to y by 1 minus theta ij. So I think we should be able to find out the theta ij here, because 1 minus theta ij by theta ij equal to y. 1 by theta ij minus 1 equal to y. 1 by theta ij equal to 1 plus y. Theta ij is becoming 1 by 1 plus y. So this is the kind of an estimate that is coming out for theta ij. So in this case, I can very well estimate the value of the parameter as theta ij is 1 by 1 plus y. Probably you have to make it much more better, because this y could be differing for different scenarios. I can even make it as yij, right? So that is what is the parameter. Fair enough. And now we are saying, show that probability of yij equal to y can be written in the exponential form of family form. Okay. So what is the yij equal to y here? This is the one. So I have to write it in the form of an exponential family. So theta ij, how can I write it in an exponential form? E to the power of log theta ij. Fair enough. And this I'll write it as e to the power of log 1 minus theta ij to the power y. So which means this is e to the power of log theta ij, e to the power of y log 1 minus theta ij. Okay. So which becomes e to the power of log theta ij plus y log 1 minus theta ij. And now if you start, if we remember, the exponential family is of the form e to the power of y theta minus b of theta by a of phi plus c of y comma phi. So this is the typical exponential family that we are aware of. So if you try to look at it, y theta, so here I can very well visualize that my theta is nothing but log 1 minus theta ij. So this theta is actually the natural parameter, right? The other phi is the scale parameter, but this is the natural parameter. So theta I can very well take it as log 1 minus theta ij direct. And probably if required, minus b of theta I can very well think of, right? Because there is a b, if I really have to bring out minus b of theta, now that I know this is the theta, I need b of theta should be log theta ij. So I can think of, right? So theta is log 1 minus theta ij. So I can say e power theta is equal to 1 minus theta ij. So from here I get theta ij is 1 minus e power theta, and as a part of b of theta I need log theta. So because I need log theta, I can very well think of, right, theta equal to 1 minus theta ij. So this is 1 minus e power theta. So I can very well think of log theta ij is nothing but log 1 minus e power theta. So this would be my b of theta. I can very well plan out. Now a of phi, I'll call phi equal to 1. So a of phi is also 1. So and c of y comma phi, I can very well make it as a non-existing one. So probably I can very well think of log 1 minus theta ij is the natural parameter theta for this exponential family of distribution, right?